So the next key skill we'll need is our Pythagorean Theorem. The Pythagorean Theorem works only for right angle triangles. So don't try and use the Pythagorean Theorem if you don't have a right angle triangle. So you have to have a right angle in here. The hypotenuse is the side that is opposite the right angle. So this side C here, that's the hypotenuse. A and B are the two sides that are close to the right angle. So there's A and there's B. And then the Pythagorean theorem is simply that those two sides close to the right angle squared, so a squared plus b squared, will add up to the hypotenuse squared, c squared. All right, so trying an example with that. Let's say we've got this right angle triangle here. My Pythagorean theorem is that a squared plus b squared equals c squared. The hypotenuse is the side that's opposite from my right angle, so that's the 26. So C must be the 26, and C is going to be squared. A is either one of the sides that is beside the right angle, so the 10 or the x. It doesn't matter which one. So let's make A the 10, and then B would have to be the x there. If we want to solve for what x is, all I have to do is rearrange this for x. So I'll get x squared is 26 squared minus the 10 squared when I move the 10 squared to the other side. 26 squared minus 10 squared is equal to 576. That equals x squared. Don't forget to square root both sides at the end to get x on its own. So the square root of that is 24. So that means this side here must have been 24. All right, the really interesting thing to do, I find, with the Pythagorean theorem is to prove why it's actually true. So for this, what you'll need is 8 triangles, and these will be right angle triangles that have a side A, side B, and then a hypotenuse, which is C here. You're going to need 8 of those. And then you're also going to need an A squared shape, which is literally a square that has sides A by A, so its area will be A squared. So you can see how it fits nicely here against side A. You'll have another square which is literally B squared, so that has side B by B, so its area will be B squared, and a square which has side C by C, which makes the area of that C squared. So 8 triangles, 1 A squared piece, 1 C squared piece, and 1 B squared piece. I'd like to actually pause the video here. What your goal is going to be is to arrange those 8 triangles, the A squared piece, the B squared piece, and the C squared piece, into 2 squares, so you can divvy them up between the 2 squares. The key is your 2 squares have to have equal areas at the end of the day. So pause the video, try and figure that out yourself. Okay, hopefully you got something like this. So hopefully with one of them, you put maybe the A squared shape right here. There's actually a few different solutions, but this is one of them. And then maybe you put a triangle here. So this would be side A of the triangle. This would be side B, and that's side C. And then there's side A here, and B, and side C is in the middle. And then you could actually put your B squared shape here, right? Because if this is side B, I can make this also side B, and this would be B squared in here. Then in here, I could actually fit 2 more triangles. So this would be side B by A, and that's C, the hypotenuse there. That's going to be A, that's going to be B there. What you'll notice is that the total area of this rectangle is going to be A plus B, right? This is A, this is B here, and then here we've got A plus B. So this side is also A plus B. So the total area of that square is going to be A plus B squared. Now, how can I make another square that has exactly the same area as that? Well, what I can actually do is kind of put my triangles here. So this would be side A, this is side B, and that's side C there. I want this to have the same area, so this is going to need to be B there, and that would mean that's A. This is going to be B up here, that's A there, that'll be C, that's C too. And here we have A and B and C. So what you can see is this side is going to be A plus B, right? That's the length of this side. And this side will also be a plus b here. In the middle here, I have a giant square which has a side length c by c, so that is c squared there. So these two squares have exactly the same area. Their area is a plus b times a plus b, or a plus b squared. And we've used up all 8 triangles. There's 4 of them here and 4 more of them here. We've also used up our a squared shape, our b squared shape, and our c squared shape. So what I know is that the two areas of these are equal. So if I write down what is the area of this square on the left here, well, there's 4 triangles, right? Sorry, that was a bit messy. Try that again. So there's 4 triangles, and then there's a c squared shape. And that makes up the whole area of the square on the left. The square on the right has 4 triangles as well, right? 1, 2, 3, 4, but also has an a squared shape and a b squared shape in there. Now what I can do next is, I know these two areas are equal, right? Because I've intentionally set that up that way, that these two squares would have equal areas. So what I can do next is actually just subtract 4 triangles from both sides, right? So subtract 4 triangles here, subtract 4 triangles there. And that is going to get rid of the 4 triangles, get rid of the 4 triangles, and you'll be left with c squared on this side is equal to a squared plus b squared, which is indeed the Pythagorean theorem right there.